Hi guys, this is Jagdish. Today I am going to help you how to build a house price prediction model using linear regression algorithm. So my first question, what is linear regression? You have any idea? So if you don't have an idea, so you may have Google. Go for it, search linear regression so that it shows you answer. Linear regression is an algorithm used to predict or visualize a relation between two different variables. Okay, relation between two different variables. What are that variables? Let's search. Here it's given independent variables and dependent variables. And this is the straight line. You may have learned in 7th standard y is equal to mx plus c straight line equation. This is line of regression. So what are independent variables? Independent variables are the inputs, dependent variables are the outputs. Okay, in house prediction model, what will be the independent variable? Independent variables may be inputs like for bedrooms, number of floors, location, prices. Sorry, prices comes under dependent variable. So dependent variable will be the price because it's the output. Independent variable will be the parameters which we are giving to predict a price. Okay, now you got an idea what is linear regression, and now we need to build a linear regression so that it appears like this. We need to adjust in y is equal to in equation y is equal to mx plus c. So y is given, x is given. We need to find m and c. M is the slope, c is the constant. Okay, let's start. So before starting, we can build a model, but for built-in model, we need a data set. So where we get the data set? So we have another website for it. So just go for Kaggle. Here you can find many data sets here. House price prediction data set. So here you can download. It's around 5.7 MB. Here is the option download. So you may download it so that here you can see BHK number, BHK or RHK. Wait a minute, scroll down. Here address, ready to move, resale, longitude. So this is the dataset. Here you can download. I have downloaded before itself. So we downloaded the dataset and we decided which algorithm we are using to build a model. So where we are building a model and how we are building. These are the two questions we arise. So I am preferring Google Colab. So you can build a model in Jupyter Notebook also, but I prefer Google Colab because it's faster in training. Jupyter Notebook comparatively slow, and in Jupyter Notebook we need to download many models like numpy, pandas, matplotlib. We need to download it, but in Google Colab it's a cloud so that we don't have to download. Okay, let's go for Google Colab. Open the drive. So my drive is already open. So here the option plus and here option more. So wait a minute, collab is opening. Okay, wait until it shows here connected. Oh, connecting to runtime to enable the browsing. So here, look it, it's connecting. Wait for it. So it's connected. Now we need to upload our data set. So here in sample data, here option upload. So from here we can choose and we can upload data set here. I have already uploaded. So California house test. Wait a minute, I will show how my data set looks here. Longitude, latitude, total rooms, total bedrooms, population. Because in by the population also the demand increases, house prices may increase. So median income, median house value. So it is the price of the house, median house price. So by using this California house data set, we are building a model and we are training it by using this model. Okay, now let's start coding. So first step, we need to import our data, import some libraries. Second step, we need to visualize the data. Third step, we need to fit it in linear algorithm, linear regression model. And fourth step, predicting its mean square error and absolute error. Okay, let's go for first step. Before going for first step, here we can name it as, wait a minute, house comma p, so that we can know that we are building house price prediction model. So first step, we need to import some libraries. These are the libraries we need to import. So import numpy as np, import pandas as pd, import seaborn as sns, and import matplotlib as plt. Why we are importing these libraries or models? So numpy for maths calculations, pandas for data visualization, seaborn and matplotlib for graphical representation. So let's give shift enter. If you use shift enter, it runs. So this cell successfully cleared without any errors. So that next step is uploading the data or else importing the data to model. Let's go for second step. In second step, we are importing data. So importing data and checking out. HouseDF is equal to pd dot read csv. This is the function. Okay. So we need to give path of the data set. So go for here in sample data set. In sample data, there is a California housing test CSV. So in three dots, press on three dots. So it gives copy path. Copy that path, paste it here. So we are given that, just write HouseDF. So to check whether we have uploaded data or not. If you give a shift enter, see that there is 3000 rows and 9 columns. So we successfully imported California test data to HouseDF. So that next step is visualizing it. Okay, how to visualize? So just we can print head here. Out. In third step, we are visualizing data. Just give head HouseDF.head, shift enter. It prints head. If you give tile, just a second. HouseDF.tile, shift enter. So last data set 299, because it starts from 0, it ends at 299 because we have only 3000 rows and 9 columns, so that it prints last 5. In this way we can visualize the data. Let's describe our data set. For describing our data set, we need to write HouseDF.describe, give shift enter. It describes our dataset: count, mean, standard, mean 25%, 50%, 70%, max. So every 3000 rows, count 3000 rows for every column, mean of every column, standard deviation, minimum of every column. So 25%, 50%, 70%, max of every column. In this way it describes. So let's go for fourth step. In fourth step, we are visualizing graphical representation of dataset is done using SNS. Here we imported seaborn as SNS. Just look at here. Give shift enter. It may take time. Let's wait. Oh, ज़्यादा टाइम लग रहा है. Guys, you need to bear with my English so that I am not a perfect speaker, but I am trying to explain you. Sorry if I have made any grammatical mistakes in my English. So we got the graph. Wait a minute. You can see graphical representation. These are the columns. Just you can see longitude, latitude, house median age. So if you think this as hex, longitude as x, and mean, median, house value will be y. This will be x column for everything. This will be y, so that you can see graphical representation. So we can represent this in, there is a tool called Tableau. There also we can represent this kind of graphs. Okay, we can use matplotlib for representation this. So now let's go for next step. In this step we are visualizing mean value, median house value, means the price of the house. So give it. So sns.distplot HouseDF median house value, give shift enter. So density versus median house value. We can see the graph. Okay, let's go for next step. Okay, next let us print heat map. Guys, these are the functions you need to go through Google so you get an idea. So for time convenience, you take it as heat map function itself. So you can see the heat map here where longitude, latitude, median and median income. Okay, let us go for next step. Guys, we imported the data and we visualized the data. Now we can go for building our model. So we need to decide which are the x values, which are the y values. So as we know, x is an independent variable. So longitude, latitude, house, total rooms, total bedrooms, population, household, median income comes under x variables, and the price, the median house value comes under y variable. Sorry, control V. So you can see x of HouseDF, all the values longitude, latitude is given to x and median value house value given to y. The value is given. After assigning x and y values, we need to split our data set for training and test data set, so that we need to from sklearn that model selection import train test split. This is the model we are importing from scikit-learn. So we are assigning, look at here, test size is 0.2, means 20% of is given to the test dataset and another 80% is given to training dataset. So just give run. So for your convenience, I print x train. Look at here. X train is not find. Sorry, it's caps x. So you can see 2400 rows were given to x train. What about x test? So 600 rows are given to x test dataset and 2400 rows were given to x train dataset. So in this way we are splitting our data to x train and x test dataset and y train and y test dataset. So in this way we are splitting. Next step, we are importing linear regression model. So there is a built-in model in scikit-learn. So we are importing the linear regression model and fitting the data into it. So let's go for next step. Here it comes. So we are imported linear regression model. Sorry, linear regression algorithm. So and we are giving LM. We are giving linear regression model to LM. So we are fitting X train and Y train in LM model. So give print. So here intercept is true, n jobs is none, normalized false, So linear regression copy x true. So we are successfully fitted our x train and y train dataset in linear regression model. Now let's go for prediction and check our training model. So prediction. So we are fitting up for predictions lm.predict x test. So next we can visualize what is the prediction is. Just look at this. So it is a straight line. So our prediction model is pretty sure it's awesome. So that we predicted. So wait a minute. You can see linear regression. Look at this. So in this way our model also predicted. You can see, but here some errors there. So that we can check what is the absolute error and mean square error in next step. So for checking absolute error and mean square error, we need to import matrices. So from sklearn we are importing matrices, and I am checking mean absolute error and mean square error. So mean absolute error would be 53145. Mean squared error will be 541,605. And then in last step, I am printing y prediction. Sorry, the predicted graph. So y test predictions. So here you can see. So test versus prediction. So that this is the predicted graph. This line represents the prediction of the price, and this is the test. So pretty sure that our model is very good. So this is house prediction, house price prediction model using a linear algorithm. For next videos, I will come up with other using other models, house price prediction using other models. Thank you for watching this video.